In this problem, we're asked to draw ethers that satisfy the molecular formula C5H12O. So an ether is an oxygen in between two carbon atoms. So you can't do 5 carbons in a chain because we don't have any more carbons on the right. So we could do 4 carbons and then an oxygen and then 1 carbon. Okay. We could do 3 carbons and 2 carbons. Okay, so that has a total of 5 carbons. And that's the same as 2 and 3, or yeah. So now you can think about branching. Okay, branching. So 3 carbons can exist as an isopropyl group. Okay. Let's consider branching of this this guy here. So 4 carbons can be a term-butyl group, could be a sec-butyl or an iso-butyl group. So something like that. Something like that. Okay. So let's name these. This is butyl, and this is methyl. So alphabetizing this, we would write this as butyl methyl ether. Here, this is a propyl, and this is an ethyl. So alphabetizing this, we would call this ethyl propyl. Misspelled that. Propyl ether. Okay. This guy right here is an isopropyl group, and this is an ethyl group. So ethyl isopropyl ether. Okay. Over here we have a term-butyl group and a methyl group. So we would alphabetize this term-butyl. Okay. Here we have a sec-butyl group and a methyl group. Here we have an iso-butyl group and a methyl group. For the butyls, there's this hyphen there between the butyl and the tert or sec or iso. So the rules state that we alphabetize based on the butyl, B for butyl, and not the T or the S or the I. For isopropyl, there's no hyphen between the iso and the propyl, so the rules state that you alphabetize the I for the isopropyl group. The reasons are beyond me, but this is how you do this problem. Let me carefully look and see if there's any that we've missed. So We have the 3 chains, which is propyl and isopropyl. We have the 4 chains, which are normal butyl, tert-butyl, sec-butyl, and iso-butyl. And we can't have any 5 chains. So these are all the possible isomers you can draw that are ethers and satisfy C5H12O. Now, it's not going to be a ring because let's just draw a ring here. So here's 5 carbons, 1, 2, 3, 4, and 5. And if you just draw a line drawing, you might think, well, that's great. Let's name this. But count the hydrogens carefully, and you can see that there's 2, 4, 6, 7, 8, 9, 10. So this guy right here would not satisfy the correct molecular formula. We need 12 hydrogens. So this formula here would only be satisfied by acyclic ethers. Also, you might be thinking, well, what about, something like that with a double bond? And the same situation arises. If you count the hydrogens, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so there's no unsaturation in the ether, okay? They're just acyclic aliphatic ethers. And these are the drawings, and that's how you name them. Thanks for watching. If you like my channel, please consider subscribing.